Hello and welcome back, my dear brothers and sisters. Today we will be redoing our networking stack. In our Kisa project, Kisa is an editor which you can use to edit any file in any language with maximum ease, but it is not ready yet, just yet. Just you wait, it will be ready very soon, maybe a year or two, and it will be ready. So let me first explain what is our current situation. In fact, we have a working stack. It is in transport.zig. And if we look here, we have sec packet. It is a kind of network. This is Unix, right? Unix is Unix domain socket. There is an option for TCP socket and Unix domain socket. This is more of how the operating system instantiates the very everything is a file in Unix, right? So the very file, how is it instantiated? Is this local? For example, is this somewhere in TMP like socket like this, or does it have an address like this? Right, this is the difference. Current one IP address is for TCP socket, and if we look at man socket, I believe, or somewhere else, we should somewhere find the sec packet documentation. Maybe we can go read, maybe connect. Sec. Okay, let me socket OS socket. These flags are documented somewhere. We just have to find it. Maybe here, socket is used in socket for sure. Socket, maybe it says where to look at. Oh, I think it is because of this tickle commands. We need Unix documentation. It's number 2, I believe. Okay. So yes, this is our AF Unix local communication, just what we need. How about sec packet? Right. So this is the thing. Sock stream, DRM, sec packet, they work fine. Raw, DM, sock packet, they kind of packet is obsolete. It's even written here, RDM and raw. I have never seen them being used. Maybe they are used on some even lower level, but not for our case for sure. When I was designing the networking stack initially, I thought, sec packet, very good balanced decision. It is a connection based like sock stream, but it also has message borders. Yes, borders like diagram. So it's like a combination of both. Best of both worlds, as they say. But sec packet, as I believe, is only available for local Unix socket. This means there is no TCP, there is nothing. We can't use TCP stack for anything. And on some systems, local Unix domain sockets may not be even implemented. For example, take Windows 10. They only had some later release added the implementation of a Unix local domain socket. So it is not the best solution, as I can now see. And our current task is just to use sock stream. Okay, back from a quick pause. I had to do something so my laptop doesn't blow up because of heat. Okay, so this is SockStream is our way of doing things. It supports TCP, it is connection based, it supports Unix domain sockets, just everything we need. Even if it only if it had the borders between messages, that would be like perfect, just perfect. But we have to work with what we have. No other way. And for borders, let's figure this out right now. For the borders between messages, some protocols that I have reviewed, for example, Emacs uses new lines as the end of the message. Cocoon uses new lines, and maybe it's just a good choice. So I don't see a reason why we should not copy it. So, okay. I don't believe we need our current implementation of these with this sec packet and so on. So we just can rewrite it, not create another option like a transport kind. Don't really need this, right? And do we have tests? Okay, we have with a fork 1. Oh, it's a watcher. Right. It's a watcher even. Well, okay. I believe we can have our test transport fork 1, fork 2. Let's go to build file and make sure that our transport tests are going to be run okay. Transport. Okay. Oh, I see. I have just two. These are two separate. Okay, transport fork 1, transport fork 2. Let's go. Transport. Yeah, okay. We see 3 tests passed, but it's just because of forking. Let's go back and start. So first thing we need to guess what is the zig for sec packet. I believe it's just a stream. Should be all right. Okay, this is for binding. This is for the server. I am a server. I want to create a socket and I want to bind a socket to address. In our case, it will be a path on the file system. And I want to listen, which means, okay, I'm ready to accept connections. See? Okay, pretty easy. And this is for the client. We again create a socket, same command, nothing new, and we try to connect to the server. Right? We may not succeed from the first attempt because server and client may be started in separate processes. So what we are doing is just retry every time and wait for the server to finally start listening and accepting our connections. Yeah, this is path for Unix socket. It's pretty complicated, but nothing too new. Address for Unix socket. This is like same path, but in the net address. And this is mixin, I believe. Oh, here is a mixin. Right. This is a mixin that we are going to use. And this is something else. Not really important, I think. Send, receive, read packet. Okay. So let's read this to do. Allow the caller to pass packet buff. So I believe it is for performance, right? Something like that. Send a message. Message must implement because it's any type. So here we write in text. Message must implement generate, receive in a buffer, and put in a slice of U8 content into it. Okay. Contents. I recently checked. It is correct. Content is about a topic, like a main plot. And contents is what is actually contained inside something. Okay, let's continue with what? Generate, send, packet buff. Okay, I believe that what we want is to add a new line at the end of this message. Message generate and add a new line. Okay, so can we know the length of this packet? We should know, right? I hope so. Let's go to generate. It is probably message generates, probably in RPC. Message. We don't have it in message. Where is it? JSON RPC. Generate. Here. Yeah, we get a slice and yeah, sure. Let's do it like this. This is our packet buff. This is the buffer. This is packet size. It's a lot more than what we expect to get. This is a slice. So what now we need to do is to go like this. Packet buff. Length. This is the slice. This is the length of the slice, and if we put it like this, len, it means the symbol right after that slice. And we just put a new line here. And what we do is we say const packet with new line equals packet buff from 0 to packet.len plus 1. Perfect. Right. And then packets len. Yeah, we need to make this assertion here. Okay. Send is done. Now receive. Let's go and receive. Self read packet. If we have a read packet, this is if it is not null. If we have read packet, then we try to parse it. Otherwise, return null. Okay, this is for receiving a null message or no message. It's okay. So this is our main function. Read packet bytes thread equals 0 return null. That is okay. Buff len bytes thread message to big return buff. I believe this is not going to be entirely correct. Because we are going to receive it as a stream, and we need to read up until a certain character, new line in our case. So can we do this? OS receive. Let's go to Zig documentation. Zig Linux. Yeah, that is okay. Lib std and go to OS, I believe, and receive from. Okay, maybe this is going to be a little bit more involved than I have thought initially. we don't seem to have this option. Is there some convenient interface for these actions? Because OS layer does not seem to provide necessary things for us. Let's try to find it in the Linux manual. Receive from, receive message. Okay. Okay, so far nothing too useful. Flags, I don't believe we need any flags. Receive from is pretty standard. Do we need receive message? Is this how we're going to do this? I don't believe we can have receive message on the TCP stack either. So we're not going to win anything from this. Is this correct? I don't know. It's not really well documented. Okay, it is this scatter gather locations with read v for IOVEC types. Yeah, I don't believe this is what we need. Okay, let's maybe just do some random searching network. Simple network protocol, managed network protocol, UEFI. Yeah, I don't believe we need UEFI. This is like bindings for the C. Yep, I don't think it is what we need. How about there is a buffered read, right? We can have buffered read, for example, we have read something, we have read a packet, but here we can receive more than a packet. You see, if we receive, if our message is, for example, right, if our message equals 6 bytes plus 1 byte new line, 7 bytes, and then message 2 equals 8 bytes plus 1 byte new line, 9 bytes, and we say okay, receive, and we get like 10 bytes. Right, so what are we going to do? We need to get the first message, right? We get message 1, let's call it message 1, and some bytes, like end bytes. And these end bytes belong to the second message, but we only wanted to read the first packet, right? Yeah. That is uncomfortable situation, of course. I believe we need some state, some buffer for buffered read. And I do not like it too much, but maybe it is going to work. This is communication mixin, so we need some space, we need some buffer to do some buffered reading. Yeah, buffered reading, buff reader, fixed buffer stream. Buffer reader. What about fixed buffer stream? This turns a byte buffer into an IO writer, IO reader, or IO seekable stream. Oh, okay, it's for byte buffer. It's after we have read it. Okay, maybe buffered reader. So what do we have here? Reader. I believe this is what we need. So just to briefly explain what buffered reader is. We have some space. And we read into it. And if we want to say, okay, so I want just this little part, I want to consume it, and we consume it, and everything else is kind of cached here. It's still stored, right? And you can continue reading after this, but you just need some space to store the parts that you have not read yet, or that not that you have not read yet, but the part that you have not yet used in your business logic, in your application. And in this case, we have read 10 bytes in our buffer, for example. We will read message 1 and say, okay, discard the first 7 bytes. We don't need them anymore. It will discard it, and these bytes will be still here. The next time when we read, we will read how many? We will read, this will be not n, but message 1 plus 3 bytes, and we have read 6 bytes, and we get our message 2, because we get 3 bytes from here, 6 bytes from here, and it is exactly 9 bytes of the second message, right? Let's try doing that. Bytes read. Okay, so everything we need is just to implement a buffer read on the unbuffered reader. Okay, we need a reader somehow still. Maybe socket OS, socket POSIX, this X experimental socket. Do you have a reader interface? No, you don't have it. Okay. Different socket options. And we don't want... by the way, are we... can we do Windows still? Or are we forced to be on Linux forever? I don't remember we have made the decision. So we are not hard-coded to be on POSIX systems. So I thought about looking at socket POSIX. Maybe there is something else, but no. No. We should be true to our cause. We should be cross operating system. An adjective from this word, cross operating system. Okay, let's do a quick reader implementation, I guess. Reader. IO bit reader, buffered reader, counting reader, bit reader. Okay, we just need to implement the reader, right? We need read fn. Context, read error, read fn. Okay. Let's go and find something that has this interface. I think ArrayList is very good example. Reader. Okay, it doesn't have a reader. Oh, does it? Does it? I remember there was something. Oh, it has a writer. Well, at least the writer. Okay, let's just try doing this. We need communication resources, communication mixin, and we can do just right here, I guess, right? Const, how do we call it? Socket reader. Okay, socket reader. Why not? Why not? So we need what? This tab. Context, read error, redefine. And redefine accepts context and buffer. Okay, so what is our... Let's copy this line here. So first of all, what is this 0? Is this null or something like that? So it is flex. Oh, right, flex. What about flex? I am now interested in flex. Receive message, don't wait, non-blocking operation. Yeah, I think this didn't work on my system, so I just don't use it. RQ, something. We don't need errors, we don't handle errors, just error. Okay, crash. OOB, out of band. It's just about something priorities. I'm not sure it even works. Message peak. Yeah, all these flags, they may be working on network TCP, but on Unix domain socket, I don't think they work. At least the ones I tried, no difference. No difference. Okay, this is what we have. Now we need to implement is even a struct reader as a struct. Okay, so we return the struct. She has a context, which is OS socket T, which has read error, which is OS receive from error, and it has read fn, pointer to the function that will do the reading. Here it is. Return the number of bytes read, maybe less than buffer.len. If the number of bytes read is 0, it means end of stream. End of stream is not an error condition. End of stream. I don't like that 0 is end of stream. What if we have read 0? Okay, for our application I think it will be fine, because we use the polling, select in this poll, select epoll, kq, whatever, and we always know that there is something to read. We will not read otherwise, we will not read 0 bytes, so we should be fine here. Okay, and this is context buffer. Let's just copy this function signature. We need to define it, right? Struct, maybe even somewhere here. Socket context read function. Can we define it right here, like so? Read function. Is this going to work? I don't know. No idea. Is this even correct? No idea too. No idea too. Context, buffer, read error. Here is read error. Maybe we need to be a little bit more specific. This is like this. Context is here. Buffer. OS receive from error. Like so. And do we return usize? Yes, correct. We return the usize. Okay. I hope this is going to work, because otherwise, let's call this socket for consistency. Read function. Okay, so we have our read function socket reader. And I believe we need to do an init, right? Right? Byte thread. Need to do init with a socket, and we get a reader instance. The socket reader is our reader instance, like so. Pub-fn init. Oh, I don't like it. I need some example. Let's go to file, maybe. FS file, reader. Okay. Read R. Read, read all. How about read R? Reader. Okay. So this is how it is implemented. We need context.file, IO reader. Just so simple, IO reader. Oh, this is just a function that returns a type. Oh, I'm so dumb. Okay, and the context is file. And the read function is... How do you get the read function? Oh, first you create a type, and only then you create an instance of this type as a reader. Okay. So let's just rewrite it. Const socket reader equals, do we have IO? Okay, no problem. Reader, this is the function that creates a type. Now we pass it the type OS socket T, OS receive from error, and our read function socket read, like so. We will call it socket read. Now we don't need that, and we can do pub-fn reader. Finally. Reader socket os.socket t. We get our socket reader, and we return the socket, maybe even like so to be cool. Yes, like so, with a dot, because it infers the type from the return specification we have already written. Okay, we have our socket reader type, we have our read function, and we instantiate our type. Now we need a buffered reader. How do we get a buffered reader? Buffered reader. Do we have a test? This is a test. Okay. 1 byte stream. 1 byte reader. Okay, 1 byte reader. Okay, it is buffered reader, buffered reader, 1 byte stream reader. And we get a reader from this again. Okay, this is stream. And stream, finally we can use all the reader functions. Okay, great. How about the buffer? Do we pass the buffer for our buffered reader? I'm confused. We need here we need a buffer size, right? Oh, here we have a function. Okay. By default it is 4 kilobytes. Okay, I think why not? Right? Let's go here. So what we need to do is to just replace this line with our reader implementation. Okay, let's start. We need buffered reader and reader. Okay. Reader, PubFan reader, socket. Okay, we have a socket and we can get a reader from this socket. So we just use var socket stream equals reader as.socket. Self.coms. What is coms? Communication? Something like that. Communication container. This is here. Yeah, okay. It's not something too important. We can continue with this. Var buffered reader equals. What is this buffer exactly? Buffered read is just a part of here. FIFO type init. What is FIFO type? Where is it? Here, static buffer size. Oh, okay, so we just statically initialize the buffer for our caching. So this does everything for us. Very beautiful implementation. I don't even need to pass any buffers. Okay, after that we do what? stdio buffered reader, and we pass the socket stream. Okay. Buffered. It's not buffered reader, it's just buffered stream. Or ability flex. So buffered stream is buffered reader.reader. Oh my god, so many readers. Is this right? Stream buff reader. Okay. We just say it like so. Now we byte thread null. Can we return null? Let me see. Yes, we can return null. Okay, if byte thread equals 0, return null. Okay. Maybe we even want buffered reader implementation of our own, because we can have maybe large packages. This is our max packet size. I believe we should reuse our max packet size. What's it even? Max packet size. 16 kilobytes. Wow, we are very generous, very generous. But it's okay, it's okay. Let's quickly create our own type for this buffered reader. Buffer size, comp time, reader type. Okay. Our size is max packet size, and our reader type is socket reader. Okay, and we just use this instead of our function here, like so. Yes, looks like it. Context, is it context? Unbuffered reader, unbuffered. Yeah, like so. Now, we need to read it into a buffer. This is our buffer, and we need to read into it. So let's open some read routines. Where can we find the reader? I believe here. Read all, read either until the end of stream is found. Oh, read until delimiter. I like this. Read until delimiter alloc. Read until delimiter. Oh, this is what we need. So we get what? Get buffer back. Our don't get a number, but we get red buff. Let's call text this. We get our stream and we say read until delimiter, and we go with our buff like so, and delimiter the new line. And here we go, if red buff.len equals 0 like so, then we say that if like so, if we filled in all the buffer, we say message is too big, and we return this one in full, read buff. Okay, so we have introduced the socket reader, we have buffered reader, we have introduced send and read packet. There is a little concern that our buffered reader might not actually work because my computer is too fast and all the messages are consumed in full, and there is no situation where we can send 2 messages and consume only a single message. But maybe. So now is our most favorite part, where we look at Zeke shouting at us. Oh, so look at it, so fast, marvelous. Socket. What do you mean? Oh, maybe return. Oh, so fast. Use undeclared unidentified buff. Sure, it's called buffer here. Analysis. Now we needed an analysis. Okay. No member called unbuffered ubuffered reader. Well, ubuffered reader, of course not. Maybe unbuffered reader. Okay, bufflan. Oh, I guess we need to do the try here because it is a reading operation and it can fail. What? Why? What? It just worked? Okay, I'm very concerned. We have probably made a great mistake somewhere. Why did it pass? First try. And after how many, like 4 messages from the compiler? Come on. That is not real life. We have somewhere a test where we sent a couple of messages on the socket. Let's go and look at our tests. Transport fork 1. Okay, so what we do? Let's go line by line. We get pass. We get our address. Then we do fork. This is our server part. We do listen. We listen for connections. We initialize our server, create buffer. We receive a message. We assert that the message is not null. Client just send a message. Okay, very boring. So I believe this is here with the watcher, right? With watcher. So I believe we don't need to modify the watcher. It's pretty complicated, and we might get into some unexpected errors. That this code is too old. I don't remember it too well. I believe this is the easier option to just modify this one. So sending and receiving. I believe we just need to send a lot of messages and not read them here. Here we read a message. Here we send a message. Are we at the stage where we want the message to have a content, a specific content? Because we also need some new lines, right? Okay, let's spend our little time we have left on the messages on this test. My message. What does it even mean, my message? Generate parse. Oh, it's specifically for this test. Okay. Generate parse. We have generate, right? Why do we not use generate? Do we use it? Oh, it just needs to have this generate. Okay. Content. What is content? How is it used? Oh, so we have always same message, generated message. Maybe it is not correct exactly. Generate parse. Well, it kind of makes sense because we don't we don't really test the message itself. We test just the networking stack, but at the same time, it might be useful to test that the message is actually correct. Okay, let's maybe modify this implementation a bit. Our message str any type. Why is it any type, by the way? Why is it not self? Okay, let's just try to modify it little by little. And add changes to the git index, because we don't want to be in a situation where we forgot something or added something we didn't want to add. Strlen. Okay, how about this? Strlen. Message.content. Here like so, and content generated string 1. So it appears it only used for the test. Oh my! I didn't want to do this. Found const expected type. Yeah, sure. Can we do it like so? Can we maybe? Oh, why do you need content to be editable? Content editable. Okay. No problem. Nessun problema, señor. Now I don't like it. Why is it still complaining? Expected type slice of U8 found const. Yeah, we need a slice, and this var, why is it const here in the type? Okay, the hardest part. We have like std, mem, span, something like this. Is this going to work? Well, it is close. It's still const, though. My God, these strings are the most craziest thing in this zig. I like Ruby, you know, I write in Ruby. It is very simple. Just write a string, it doesn't complain about types. Maybe we need a buffer, and only then we can fill in the buffer. Oh my God, I remember we had something easier than this. Somewhere here. Tests. Oh, I think this is also consts. Okay, let's do it the stupid way. Var buff equals like so, like so. Then what we do? We do std mem copy. U8 destination source buffer source generated string. And what does it return? Mem fn copy. Does not return anything. Okay, why is it funny coloring? Okay, this is our string const str. And what we do here, we say buff 0 to the string length. Okay. Variable of type must be const or comp time. What are you talking about? Is this... Oh, right. I goofed up with the syntax a bit. Okay. Can we parse the message too? Above, we assert that it is not null. And then we also do a testing. Testing expect equal strings expected actual. Expected str1 actual const message. We need to parse a message. This is packet rather. Packet. This is packet. If packet is not null, we do const message equals my message dot parse out buff. We need the message buff here. Message buff 256 undefined. Message buffer. And the string is our packet. Right? It should be without new line. Is it? Is it without new line? Receive buff read until delimiter. Does it read until delimiter as I think it does? Is not included. Yes, that is correct. Good, good. Sometimes a lot of the semantic highlighting gets a little buggy. You need to delete and redo the change to restore the normal colors. And we get expected and actual is message.contents. Okay, should be fine. And we need str1 to be at the top level and it to be called str1 and change it here and here. Found my message. Oh, parse. Oh, I think we didn't change it here still. Let's do it string parsed message parse. Oh, this already is my message, so yeah. I confused it a little bit. That is okay, no problem. Just like so. Unused local variable. Yeah, that's correct. And by the way, here we want to do what? Outbuff string Oh my god, so what is this string? We just put the string in here, right? Into the buffer. Out buff. We say that string is string, like so. A bit silly, but we're okay with this for now. So what is not message does not support field access. Oh, okay. We have just checked that here message is not null, so we are safe to do this operator. No member named contents. Well, now it is. Okay, let's go with contents. And a little bit up. Error is ignored. Testing. Yeah. The testing should have a try statement. Try. Oh, we just changed here. We just changed something here. It's not like... It's not too much. It's not too much, right? So we need just to add another United string generated string. It will be like so. String 2, and we do same stuff. We have buffer. We do a single receive, right? Single receive. I believe we will have to do some timing stuff. We need to send the message multiple times. Don't like it too much. Don't like it too much. What can I say? So basically we need to do something like this. But here is string 2 and here is string 2. This is the first message here. Second message here. And now what do? We politely ask the server to wait. Is this correct? Do we do waiting somewhere else? Oh, yes. We need to also receive it multiple times. So something like this. We receive it again and we compare it to string 2. Okay, so what we do? We listen on the server, we accept the socket, then we wait. Maybe. STD time, sleep, nanoseconds. STD time, ms per ns. No. ms per s, ns per s, ms. Let's wait for half a second. Should be enough. Let's go. Oh, this is what I was waiting for. Beautiful. we finally see that something is not working for us. End of stream. Error pass already exists. Well, this is not the error I was expecting. Make directory. Okay. Read byte. End of stream. So did we was it in the second attempt? So 376. So this line caused an error. End of stream error. Let's go and look at what the OS has for us. Receive from. Unblock, connection refused, message too big, socket not found. So what's wrong? End of stream. Is this an error? End of stream. There is no such error. Self, read byte, return error, end of stream. So it is in the reader interface when we attempted to read. Pass already exists. It's probably not what we should have concerns with. It's probably about creating a Unix socket. When we create a Unix socket, we attempt to create a directory, and if there is an error, we say, okay, just ignore the error. Delete file Z. Read until delimiter. So read until delimiter, it reads 1 byte at a time, and if the number of bytes read is less than 1, it returns an error end of stream. Maybe we should catch this error end of stream when we call read until delimiter. And if it is end of stream, then we just say, okay, no problem. Let's go and read until delimiter. And we say that it's not try, but we do a little bit smarter. Catch like so. Catch E error. Switch on the error. And we say if it is error dot end of stream, then what we do? Return null. Else return error. Maybe like so. Okay, message cannot be null. Okay. I see what you mean. So here we are. Oh no. We read until delimiter. I thought that maybe it is some kind of buffered reader and we should not return null immediately, but it is a read from the buffered reader, so if it is end of stream, then we should return null. This is what we do. Why? What do we actually have? What do we actually have? In the first message, second message, can we do some echo debugging, printf debugging, as they call it? So we receive it for the first time, and can we somehow get the full packet? Server receive. Go to definition does not work. My container. Okay, my container. Init with Unix socket. Okay, accepted socket. Init with Unix socket, accepted socket. Okay, the server is just this stuff, right? So what's next? What's next? Server.receive, and we receive my message. So it is some kind of RPC or library, something we have used. Communication mixin. Let's find this communication mixin. When we call receive self message type, and here we go. Receive read packet. And after we have read our packet, we return the parsed message. But we can also dig deeper, read packet. We can go here. And before returning the read buff, we can do std debug, print. Is this like so? Okay, I hope it is like so. Packet. And we say read buff. Okay, packet generated string. Why is it without the 1 at the end? We have the 1, right? No. Generated string 1, generated string 2, like so. Okay, so we clearly get the first message. What about the second one? There's some little bug somewhere hiding from us. So as I understand it, this is this a blocking operation, by the way? Because if it is, then it is clear why we are not successful, because we block here and we wait for the server to receive. Oh yes, yes. I think I know what. I think I know. We need to send several lines at once. Yeah. Let's do this. Send. Let's go to fn send. Read packet not interested. Send. Read packet, send packet. We want the function send packet. This is too hard. We want a low-level solution. Pubfn send packet, right? Read packet, send packet. Pubfn send packet. Self, and packet, and buffer of const u8. So we operate with strings on a lower level. We don't need this message abstraction yet. But here we will use our message abstraction, no problem. Packet buff, message generate, packet buff. So we would want to const byte send packet with new line. We want these two lines to be in here, like so. Send packet, these 3 lines even 4 lines maybe. And we want to do send packet self.send packet, and we say that packet is this I don't think it's right, because we need still one space. We need to make sure that this is const, right? So like so, packet buff, and we send this stuff. Okay, this should be fine. This. So here we get our packet generated message. We add the new line at the end, and after that we just increase the length by 1, so that it counts for this added new line character. And in the send packet we say that, okay, this is our packet with a new line, let's send it. Okay, byte send packet len. Yeah, should be fine. And now we can use this lower level primitive to send several packets at once. And we don't need this waiting. Let's comment it in case we just need it. I had several times when I needed to comment and uncomment this. Buff 200, we don't need this, we don't need this. Okay, so what we need is, it will insert a new line at the end. So what we need is, we need to insert string. Then we need to insert a new line. Can we concatenate the characters before? I think we can. Const str equals str1, like so. And now we can do it like this. Const message. So yeah, we first message, then the new line, because it is a packet. We it's not like a natural packet, but we do it ourselves, well, kind of. And then the second message, here it is, and it will be like a natural packet. Our program will add a new line at the end of this packet, right? Attempt to send 2 packets simultaneously. That is the hardest word I have ever seen. Like I have been learning to write it so many times. Send message. Okay. Are we Gucci? Not yet. Unused capture, use alert identifier S157. Yeah, okay. As self, I guess, right? Self.socket. Oh. Oh, this is like just a higher level. S here like so and like so. Okay, we have some problema. Here we solve problema. Okay. Do we need something here? Self-send packet, self-comms, UN is like Unix domain socket. Should be fine. Okay, maybe we can, it is a comp time int, because it is a character. How about a string? I guess you love strings a lot more. 149, of course, try. What is an reachable code on line 384? Okay, we're still receiving a message, but it is null. Let's find out why. We have packet generated string 1. Let's add more new lines to our logging, because sometimes one test run, they write some stuff here, and sometimes they overwrite what we want to see. So we need to add more new lines. So here we see it clearly, right? And we are missing the second stuff. Well, I mean, we are okay that we are missing it. Oh, I see. We create this buffer reader every time. Every time new buffer reader. The old buffer that had cache information is lost. We should cache it. We should have an internal state of this buffer reader. Oh my god. Can we create a buffer reader by saying, here is your buffer, Mr. Reader, please use it. FIFO type, static, we need a FIFO. Okay, can we use some kind of state in this mixin? I don't think it's possible actually. So once again, a lot of work to understand that in the end the design is not flawless, but flaw very full, I would say. And what do we do? No idea. Okay, well, at least it was a fun experience. Let's maybe add everything that we have. We will create a branch, TCP socket. We will commit everything we have here so far. And we say add, how do you say, transport, replace sec packet with stream, with sock stream, like so. Like so, sock packet with sock stream. We still need some place to store the buffered reader cache in order to account for several messages being read at a single time. Okay, beautiful commit message. I believe everything here is okay. Everything is perfect as always. Okay, let's commit this. I mean, okay, don't look at my password. Okay. Where is my link? Oh, it is I see. Origin, and we want to do a GitHub. I still, honestly, I wanted so badly to use the source HUD, but I still didn't figure out how to do it correctly. For now, I'll create it on GitHub, so everyone who would like to look at it is going to be fine. And we will not use the create draft pull request. We'll use the normal pull request. Why? Just because. Okay, so we have it here. We'll probably do something later. I will fix it alone. Hopefully without too many tears. But I should be fine. Okay, so comrades, this is the end of this not stream. It's not even a stream. It is without any distracting personalities like myself. So hope you had a great time. I will fix the things a bit later once I get my hands on it. And have a good day, my friend. Goodbye.